The conservation of cultural heritage is essential for keeping alive our history. To date, significant progress has been made in preserving art objects from harmful environmental conditions, such as humidity, temperature, or mainly earthquake-induced vibrations. But while seismic actions generate higher amplitude on the artifacts, the most encountered ones in museums and historical buildings are those generated by social activities and visitor circulation. My research highlights that the repetitive exposure to these visually invisible vibrations can produce long-term damages in the artworks, even if it takes several years and a significant number of cycles to get it visible. With the goal of safeguarding these precious objects from the past, I've implemented new diagnostic non-invasive techniques, since artifacts should be handled as minimally as possible to preserve their integrity. However, at the beginning of my research, I encountered challenges due to the lack of guidelines and regulations for museums, leaving stakeholders without clear instructions on how to protect these objects from vibrations. At the beginning of my research, vibrations in simpler terms originate from a source, spread through the soil, and at the end reach a building. For these reasons, I categorize vibrations dividing between internal and external sources, based on their proximity and effects on the artworks. Internal sources affect a smaller area compared to the external ones, which tend to be more widespread and have more impact on the integrity. I've worked for 1 year in a museum in Venice where I selected several artworks for more detailed experiments. At the beginning, since this method has already been tested, I've placed accelerometers on the floor of the museum to record the vibrations produced by internal sources, revealing alarming results in rooms made with wooden floors, which is very common for Italian museums. But since I wanted an even more precise non-invasive technique, I've implemented a new one. I exposed an art object, in this case a wooden altarpiece, to sound waves produced by a speaker that make the object shake, and I recorded its response with a laser vibrometer. This allowed me to understand some damages on the surfaces, like painting coming off or structural anomalies. But since this is a new technique, I asked myself, what is the sound level that I should apply to make the object vibrate like it's in a real museum? Well, my results reveal that it's easier than expected, because sound levels comparable to human voice and human conversation can provide valuable insights, proving that we can have results without touching the objects. In conclusion, my research highlights the importance of non-destructive diagnostic techniques for preserving cultural heritage from human-induced vibrations.